way we can integrate this one. So here this is only minus, and integration of 1 upon x plus 1, that is log x plus 1, and plus 2, integration of 1 upon x plus 2, that is log x plus 2 plus the constant c, which is the integration of this function, which is the answer. Okay, so in this way we can integrate this kind of functions, and we can use the method of partial fraction to do the integration easier. In this way we have find the value of a and b, which is a is equal to minus 1 and b is equal to 2, and then after that we can easily integrate that function by the formula that integration of 1 upon x, that is equal to log x. Okay, so integration of 1 upon x plus 1, that is log x plus 1, and integration of 1 upon x plus 2, that is log x plus 2, and integration constant c. So this is the answer of the second question. Now let us solve the third example of question number 4a, and the third example is, question is evaluate, this is from the definite integration, evaluate 0 to integration over 0 to pi by 2 log cot x dx. Okay, so here let say I is equal to 0 to pi by 2 log cot x dx. Okay, so we know that 0 to a fx dx is equal to 0 to a f of a minus x dx. I will write here the formula. We know that by theorem 0 to a f of x dx is equal to 0 to a f of a minus x dx. So here in this case f of x is equal to log cot x and a is equal to pi by 2. So I will get integral I is equal to 0 to pi by 2 log cot a minus x, that is pi by 2 minus x, because a minus x, here a is equal to pi by 2 minus x into dx, implies 0 to pi by 2 log cot pi by 2 minus theta, cot pi by 2 minus theta, that is equal to tan theta. So that is tan x into dx, because pi by 2 minus x will be in the first quadrant, so sign is positive, and pi by 2 here, so we will put the tan x. So our answer is 0 to pi by 2 log tan x, because cot pi by 2 minus x is equal to tan x. This is I. Okay, so in the starting we have taken I is equal to 0 to pi by 2 log cot x dx, and after all we have got I is equal to 0 to pi by 2 log tan x into dx. This is the equation number 2. If we edit these two equation, then we will get I plus I, that is equal to 0 to pi by 2 log cot x plus log tan x into dx. So we will get, by addition of equation number 1 and 2, we will get, here I will write by the addition of 1 and 2, we will get I plus I, that is equal to 0 to pi by 2 log cot x dx plus 0 to pi by 2 log tan x dx. Okay, so I plus I, that is equal to 2i is equal to 0 to pi by 2 log cot x plus log tan x into dx, right? So we will get 0 to pi by 2. This is log a plus log b, that is equal to log a into b. So we will get log cot x into tan x into dx. Okay, I have a reason. The reason is log a plus log b, that is equal to log a into b, which is the property of logarithms. Okay, so this is cot x into tan x. We know that both are inverse, so cot x into tan x, that is equal to 1. So after all we will get integration 0 to pi by 2 log 1. Okay, log 1 into dx, and log 1 is equal to 0. So in the definite integration 0 dx, that is equal to 0. Okay, so this is the answer of integration. This is, you can revise if you want to, you can repeat this example. 0 to pi by 2 log cot x, take the I is equal to the integral, and using the theorem 0 to a f of x dx is equal to 0 to a f of a minus x dx. So we will get I is equal to 0 to pi by 2 log cot pi by 2 minus x. Cot pi by 2 minus x is equal to tan x. So we will get I is equal to 0 to pi by 2 log tan x dx, and by the taking addition of 1 and 2 we will get 0 to pi 2I is equal to 0 to pi by 2 log cot x plus log tan x into dx, and log a plus log b, that is equal to log a into b. So log cot x into tan x and cot x into tan x, that is equal to 1. So log 1 is equal to 0, so the answer is 0. That is 2I is equal to 0, so the answer is 0. Here this is the answer of 2I, so the I is 0. Okay, this is our final answer. So in this way we can integrate this question. Okay, so this is the question number 4a, third example. So now let us try to solve the question number 4b. Okay, question number 4b, and 4b is attempt any two. Attempt any two, and the first one is find integration x e raised to 3x into dx. So here we want to integrate the function of x into e raised to 3x into dx. Here there is two function in multiplication, and if we want to integrate the function where there is a two function in multiplication, then we need to apply the method of integration by parts. So here first I want to remind you the method of integration parts by the method of integration by parts. Integration u into v dx, that is equal to u integration v dx minus integration in bracket du by dx integration v dx into dx. Okay, in this case u is equal to x and v is equal to 3x. So we will get integration of x into e raised to 3x dx is equal to integration of u, that is x, into integration of e raised to 3x dx. Okay, minus integration differentiation of x into integration of e raised to 3x dx into dx. Okay, so by integrating this expression we will get here this one is equal to x integration of e raised to 3x, that is e raised to 3x by 3. This is the integration of e raised to 3x minus differentiation of x, that is equal to 1. So integration, this is 1 into e raised to 3x upon 3. Okay, this is u into integration of v, minus this is differentiation of u into integration of v into dx. So we will get x e raised to 3x by 3 minus integration of e raised to 3x by 3 into dx. So in the end we will get x into e raised to 3x by 3 minus again integration of e raised to 3x, that is e raised to 3x upon 3. So this is e raised to 3x upon 3 into 3, that is equal to 9 plus c, which is the integration constant. So after all we will get e raised to 3x by 3. If I take common, then I will get x minus 1 by 3 plus c, which is our final answer of integration. So all the students need to remember the method of integration by parts, and this is the formula of method of integration by parts. Integration of u into v into dx is equal to u integration v into dx minus integration of differentiation of du by dx into integration of v dx into dx. And the selection of u and v we can take in the way of L I A T E. Okay, so that means L, that means logarithms, I means inverse, that is arithmetic, T means trigonometric, and E means exponential function. In this order, which functions come first, that is u, and the second function is v. So here in this case x is from the a. Okay, this is our x is here, and e raised to 3x is here. So we have taken u is equal to x and v is equal to e raised to 3x. So in this way we can select u and v. So this is the solution of example number 4b first. Now let us try to solve the second example of 4b. Okay, so second example is, the question is evaluate integration over 0 to 5 cube root of x plus 2 upon cube root of x plus 2 plus cube root of x plus 7 minus x into dx. Again there is the same examples which followed by this theorem, which is integration of 0 to a fx dx is equal to integration 0 to a f of a minus x into, this is the same example, just the question is different, but the same example is followed by this theorem. Okay, in the question number 4a, third example, which is 0 to pi by 2 log cot x dx, which is also from this theorem, and this is the 4b, which is also from the same rule. So here I is equal to 0 to 5 cube root of x plus 2 upon cube root of x plus 2 plus cube root of 7 minus x is equal to into dx is equal to 0 to 5 cube root of, this is f of x dx is equal to f of a minus x. So here I will put a is equal to 5. Okay, so here a minus x, that is 5 minus x plus 2, this is a minus x. Okay, and upon cube root of here also a minus x, so 5 minus x plus 2 plus cube root of 7 minus 5 minus x. Okay, so after all into dx, so after all we will get, by simplifying this one, we will get I is equal to, here we will get I is equal to integration 0 to 5, and this is the cube root of, this is 5 plus 2, that is equal to 7 minus x upon this is the cube root of 7 minus x plus cube root of, this is 7 minus 5, that is 2, and minus minus plus x, so we will get x plus 2 here into dx. Okay, this is the value of I. If you look at this one, then the I is equal to, this is number 1, this is I is equal to cube root of x plus 2 upon cube root of x plus 2 plus cube root of 7 minus x. In the same way here I is equal to 0 to 5 cube root of 7, both the values of I. So if I edit these two expressions, then I will get by the addition of one and 2, we will get I plus I is equal to integration 0 to 5, and this is the I1, so that is cube root of x plus 2 upon cube root of 7 minus x plus cube root of x plus 2, and plus, and the number 2 is cube root of 7 minus x upon cube root of 7 minus x plus cube root of x plus 2 into dx. This is the addition of number 1 and number 2. So જો અહીંયા આપણે જરા ચેક કરીએ તો બંનેનો જે છેદ છે સરખો છે, ડિનોમિનેટર આર ઇક્વલ, so we can easily edit these